Right now, the Wi-Fi in your home is arranged in a very specific shape. Your office network is arranged in a different shape. The internet itself is arranged in a completely different shape again. That arrangement of every device and cable determines how fast your network runs and how quickly it fails and how much it costs to build. Today I'm going to teach you every network topology that exists, and by the end of this video, when someone draws a network diagram in front of you, you will know exactly what you are looking at. Before we go into types, one concept you need to lock in. A network topology is simply the arrangement of nodes and links, how devices are connected to each other. And there are two versions of this: physical topology, the actual cables running through your walls, and the logical topology, the path your data actually takes. These can be different. A building might be physically wired in a star but logically run data in a ring. We will see this in a moment. The oldest topology and the simplest. Imagine a long cable called the backbone running from one end of the building to the other. Every device just taps into the cable. That is bus topology. The two ends of cable have terminators. They observe the signal so it does not bounce back and cause interference. Here is the problem. Every device shares one cable. If someone is transmitting, everyone else has to wait. And if the cable breaks anywhere at all, the entire network is dead. That is why nobody builds bus topology anymore. But it matters because it's the foundation of early Ethernet, and you will see it in CCNA exams. This is the topology you are living in right now. Star. Every device connects to a central hub or switch. Your laptop connects to your router. Your phone connects to your router. And your smart TV connects to your router. The router is the center of the star. Here is why. Here is why this design won. If your laptop's cable breaks, only your laptop loses connection. Every other device is fine. Fault isolation. The failure stays local. The weakness is obvious. What happens if the central switch fails? Every device loses connection simultaneously. The hub is a single point of failure. This is why enterprise networks add redundant switches. But for home and office use, star is always the answer. Every device receives the data, reads it, and passes it on to the next device. Only the device holding what is called a token is allowed to transmit. IBM invented this with token ring in 1980s. The benefit: equal access, no collusion, predictable, and performance. The weakness: one break in the ring and the data cannot complete the circuit. The whole network stops. Modern networks use ring topology in the backbone. Sonnet fiber networks run in rings, specifically because they can reroute in the other direction instantly if one segment fails. And that is called a self-healing ring. Mesh topology. Every device connects to other device directly. No single path. If one link fails, the data simply takes a different route. This is the topology of internet itself. Your packet from Mumbai to London does not take one fixed path. It takes whichever path is available right now. Here is the formula. For n devices in a full mesh, you need n times n minus 1 divided by 2 connections. 6 devices means 15 cables. 10 devices means 45 cables. This is why full mesh is only used where it absolutely matters. Internet exchange points, military networks, critical infrastructure. The cost is enormous. The resilience is unmatched. No real network uses just one topology. Every enterprise network, every ISP, every university campus runs a hybrid. Star at the edges, each department has switch All devices connect to the switch in a star, mesh or ring in the core. Thus, the switches in the each department connect to the core router in a mesh, so there is no point of failure between buildings. This gives you the cost efficiency of star for an individual device and the resilience of mesh for critical backbone links. When you walk into any IT job, this is the network you will be managing. Let me give you the comparison code. Bus, it's very cheap, simple. One break kills everything. Dead, techno- Dead technology. Star, medium cost, easy to manage. Hub is a single point of failure, used everywhere today. Ring, equal access. One break is still dangerous, used in backbone fiber. Mesh, maximum resilience, maximum cost. The internet uses this. Hybrid combines star and mesh or whatever maybe it can. Hybrid combines star and mesh. Every real enterprise uses this. Bus one cable, everyone shares it. Star uncentral switch, devices around it. Ring, data goes in a circle with a token. Mesh, everything connects to everything. Hybrid, the real world combination. Next week, episode 3, IP addresses and subnetting. Binary numbers, subnet masks, Y192.168.1.1 means something very specific. Subscribe so you don't miss it. Drop a comment. Which topology surprised you the most? This is CipherNest. We decode this stuff.